Hi, I'm James Eastham, a developer advocate here at Datadog, and in this video you're going to learn all about span links and how span links provide an alternative approach for understanding cause and effect in event-driven systems. Picture the scene. You've implemented distributed tracing in your event-driven system. You're happy, you can see the value, but one day you have an outage. Let's imagine you have an initial API request that comes in from your users, and that comes into the product service. They're trying to create a new product, for example. That product service then stores some data in a database. But as well as storing the data in the database, it also stores the event to be published inside an outbox, which means there's a second service here picking the messages up from the outbox and then publishing them to some kind of message channel. You've then got another service here that's picking up the message from the message channel and publishing that for other services inside your organization to consume. At this point, you've also got the inventory service, which is interested in these product created events. And you've also got the pricing service interested in these product created events. And who knows, maybe you've got 1, 2, 3, 10 other services that are all interested in this product created event. Now, in the last video, you learned all about parent-child relationships in trace propagation and how you can actually propagate the trace context between different services and visualize all them traces in one single view, which sounds kind of nice at the outset. But there's a couple of problems with this if you were to propagate the trace and create parent-child relationships throughout this entire flow. One of those problems being that initial trace is going to start here when that user request first comes into the system. That initial user request may complete in, I don't know, let's say 100 milliseconds, that first request completes. But then you've got this outbox processor that's running behind the scenes. Maybe that only runs once a minute. That publishes an event onto a message channel, which then actually does some work to then publish that message that all these other downstream services then also consume. So what is actually your initial HTTP request that resolves in 100 milliseconds may end up taking, I don't know, a minute, 2 minutes, 3 minutes, who knows? This trace gets incredibly long. The other challenge here is that this trace can actually end up being really complicated, because let's imagine you've got a span for the initial HTTP request, and then maybe you've got a separate span for the outbox worker, and maybe when that worker runs, there are 10 messages in the outbox that are waiting to be published. So you get 10 more spans for each message in the outbox. Each of them 10 messages, remember, then get passed to a downstream system. So the inventory service, the pricing service, and these 3 other services are all going to pick up each of those individual 10 messages. If you were to parent-child the relationship here, for each individual span here that gets published onto a message channel, you're going to get at least 5 more spans underneath that span. Times that by 10, you've got 50 spans, and you can really easily start to see here how you can actually end up with an incredibly complicated trace with lots and lots of spans that are kind of hard to figure out, that also isn't really indicative of the actual request, because your initial request responded in 100 milliseconds. Then you've got this kind of second flow here, which is the actual outbox worker and the message being published. And then you've got all of these downstream systems. Now, this is where span linking can get really, really helpful. Span linking is helpful here because it allows you to keep these traces independent whilst still understanding cause and effect. So let's come back to a slightly simpler diagram. You've still got this same request flow. The initial HTTP request comes into the product service, database, you've got the outbox down here picking that message up from the database, publishing that, and you've got the inventory service and the pricing service downstream. How span linking can help you here is that it allows you to keep these individual pieces of the system completely independent, because you could create one trace here just for that initial HTTP request. That would give you a trace that was 100 milliseconds that encapsulated that initial HTTP request. And then you could maybe create a second trace for the outbox processing here. And maybe that trace takes a minute, maybe 2 minutes, 3 minutes, maybe there are 10 messages or 100 messages waiting to be processed. It doesn't really matter. You've got an independent trace. But for each of the individual messages that get processed in the outbox, you can link that back to that original trace. So now you've got this independent trace that really tells you that your HTTP request took 100 milliseconds to respond. Great, you can see that, you can analyze that. And then you've got this downstream system that's working in a batch, that's processing these batch of messages from the outbox and linking that back to the individual HTTP request. So you've still got that understanding of cause and effect there. Then you've got this downstream system that is publishing these events onto this message bus that these two downstream systems are consuming. And each of these downstream systems can each have their own independent trace. And maybe the pricing service picks up these messages and it also processes these messages in a batch. So the pricing service is going to start as trace, and it's going to have these 4 independent spans for processing these 4 independent messages. And each of these individual spans can link back to the processing of the original message upstream, which then also links back to the original HTTP request that caused things to happen in the first place. So what span linking allows you to do is to keep this really clear distinction between each individual component of your system. You've got the HTTP API that's doing synchronous requests. You've got this outbox processor that's picking things up and doing some work in the background. And then you've got these independent downstream services. Each individual development team on each of these individual services can all look at their own traces, their own spans. They can still look at how their system is functioning while still understanding how all these different components link together. Now, once you've created span links in your application code, you can then start to visualize that in your observability backend. You can see this is the initial request for the product service, and that took about 120 milliseconds to respond. You can really clearly see here, this was a HTTP request. My HTTP API responds in 200 milliseconds. Fantastic. You've then got a span link here down to the outbox. This is the product services outbox. I can click that link, which will take me now into the outbox. And you can see when this outbox worker ran, there must have been a lot of messages in the outbox at that time, because the outbox has picked up this batch of messages and it's published all of these messages individually. And you can see, if you look down at the bottom, that there are 46 span links. The span links you can see in both directions. So you can see there's a downstream link to the inventory service here, where the inventory service is picking up and processing the product created event. And you can see the inventory service has gone off and done some work here to process these messages, but also the link back upstream to the product service to see the original HTTP request that happened, that in this case took 123 milliseconds. What you'll also notice in here, though, is that there is an element of parent-child relationships going on as well, because although this is the outbox processing the messages, you can see that as an individual message was processed, that was published onto an SNS topic, then onto an SQS queue, and then it was picked up by another service, which has then actually done the downstream work. So this idea of span linking aligns really well with the idea of a unit of work. As a developer, you want to be able to fully understand the unit of work that you are responsible for. That initial request coming into the product management API that then gets picked up by an outbox and then published onto some kind of central message channel, that's a unit of work that you as a developer of the product service are responsible for. What the inventory service or the pricing service or any other services downstream of you chooses to do with that event that you publish is, well, completely up to them. You largely don't care about that. You can somewhat compare this to the idea of microservices, in that an individual microservice should never expose its internal database and its internal data structures outside to other services in the system. Similarly, how a request happens to flow through a downstream service that you have no responsibility for, probably their responsibility and not really yours. So think about this idea of a unit of work. Use parent-child relationships inside a given unit of work, or inside a given service boundary can be another way to think about that. Once you start communicating with other units of work that other developers are responsible for, span linking can be much more powerful there, because it allows you all to focus on the bits of context that you care the most about. So that's span linking, a powerful alternative to trace propagation that helps reduce complexity while still maintaining this understanding of cause and effect. I'll see you all in the next video.